Disproof by counterexample. You need to just give one example to disprove a given statement. So the statement given here is that this formula will give a prime number for all positive integer values of n. So we need to substitute in a value of n, which is a positive integer, that will give us something that's not a prime number. We're going to disprove by giving a counter example. So n equals 1, we get 1. 1 is not a prime number. Or we could give n equals 8. 57 is not a prime number. Only one example is needed to disprove this statement. I've given two examples here, but one example is sufficient. Okay, this statement is saying that if b squared is greater than a squared, where a and b are just some real numbers, so if this is true, the statement is implying that b would also be greater than a. So we need to give one example where this would not be true. Okay, so I've chosen these two values for a and b. If I substitute them into b squared and a squared and check this statement, so b squared 25, a squared 9, and yes, 25 is greater than 9, the statement's true. Now let's test this one. Minus 5 is not greater than 3. This statement is false. So we have shown that this is not always true. So we have given a counter example to disprove this. Disprove by counter example. Okay, so if x is greater than y, if I was to multiply both sides by the same number, so let's call that number z, so I'm multiplying x with z and I'm going to multiply y with z, would this also be true? Now I need to give one example where this is not true. Okay, so I've chosen x equals 8 and y equals 5, and 8 is greater than 5, so this statement is true, this one. Now I'm going to multiply both of these with z. It's your choice what you pick for z. You need to pick a value so that you can disprove this statement. So I'm going to pick a negative value, minus 3. So now I need to multiply the x and the y with my minus 3. Okay, so I've done that here. So we need to see if this statement is still true. Hopefully it's not. We are trying to disprove this. Okay, so we have minus 24 is greater than minus 15, which is not true. So we have managed to disprove by giving one counter example. Now on a number line, if minus 15 is here, any value to the right of minus 15 is greater than minus 15. Anything to the left is smaller. And the minus 24 is to the left of minus 15. So we have got minus 24 is less than minus 15. That's what we've shown, which disproves this.